Welcome to the New Wave Post-Punk Security Hour, where we find inspiration from the past to make better software for the present. So even if you're frustrated that XSS and injection flaws still plague the OWASP top 10, keep pushing on frameworks to eradicate them. Like the Human League in their song Fascination with their lyrics, just looking for a new direction in an old familiar way. Which means this week we talk with Jeff Williams from Contrast Security about the need to take AppSec in a new direction of developer-first tooling to be successful in modern software development. Then in the news segment, OMI to RCE, blast door breach, building security as a product, IoT criteria, InfoSec pitfalls, and more. Keep feeling fascination and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Is your mobile app really secure? New vulnerabilities pop up every day, and malicious actors look for easy targets on app marketplaces to exploit. Securing your app's valuable IP and data is critical. GuardSquare's security solutions are built for developers and protect your app at every stage in the development lifecycle. Multiple layers of protection prevent reverse engineering and automatically detect tampering, making your app a difficult target for attackers. Learn more at securityweekly.com/GuardSquare. In any business today, there comes a moment. The moment you realize you can secure the code as fast as you write it. Instead of testing everything, you can just test the right things. It's not about tools, but intelligent risk management. That's the moment you choose Synopsys. Build secure, high-quality software faster. Visit securityweekly.com/Synopsys. Software supply chain attacks are continuing to expose vulnerabilities in organizations around the world. The time has come to focus your efforts on security for your software packages. Cloudsmith is the only cloud-native software package management solution for your enterprise. With Cloudsmith Continuous Packaging, you can securely deliver software across the globe and mitigate potential threats from entering your supply chain. With over 23 plus formats supported, Cloudsmith is the solution that engineers choose to safely deliver all of their assets. Reduce unneeded downtime and deliver with confidence. Start securing your software supply chain today by visiting securityweekly.com/Cloudsmith.
This is episode 166, recorded September 20th, 2021. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Happy Monday. How are you doing?
I'm doing quite well because I have a whole bunch of announcements to read, and that's the most exciting thing to do on a Monday, because I wanted to ask people if they want to stay in the loop on all things Security Weekly. If so, they can visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list, join our Discord server, and follow us on our newest live streaming platform, Twitch. And if you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. Jeff brings more than 20 years of security leadership experience as co-founder and CTO of Contrast. Previously, Jeff was co-founder and CEO of Aspect Security, a successful and innovative application security consulting company acquired by Ernst & Young. Jeff is also a founder and major contributor to OWASP, where he served as global chairman for 8 years and created the OWASP Top 10, OWASP Enterprise Security API, OWASP Application Security Verification Standard, XSS Prevention Cheat Sheet, hint, hint, go read it, and many other widely adopted free and open projects. Hello, Jeff. Thank you so very much for joining us.
Hey, it's great to be here.
So it's great to have you here. On the one hand, of course, just with your history within application security and driving an organization like OWASP into where it is today. But one of the things, speaking of where we are today, just as an AppSec community, we still have problems. We still have an OWASP top 10. We haven't gotten it down to 9 or 8 items on that list. And maybe it's because, well, there's probably a bunch of reasons, but I think one of them may be because we're not giving developers the right tools or the right approach to help with application security. So what's the approach here that we could do? What's something we could do differently as an AppSec community to say, hey, developers, we're actually here to help, and here's how we can do so?
Well, we really do need to think differently about the problem. As Ice-T said, don't hate the player, hate the game. And the system's kind of set up to make developers fail. I mean, if you look at software development, it prioritizes pushing software into production. The approach to security is generally the antithesis of that in most organizations. It's there's checklists, there's gates, and everything slows down the process. And developers want to push things fast. So like the approach to security that most organizations are trying to follow, and that most places like OWASP and others are pushing, are actually pretty incompatible with the way people want to build software. It doesn't have to be that way, but it is. You mentioned automation, which is one big part of the problem here. We need tools that allow developers to do their job normally. If I had to zoom out and think about like what's the biggest thing we could do to make security more compatible with the way we build software is, we need to frame up the work in a way that normal software development teams can digest it. And we can dig into more on that, but it's, we can't have like a separate process, separate silos, separate checklists, separate everything for security. It's really kind of arrogant of security folks to think that there's going to be a whole separate system just for them.
No, yeah, it's sort of, why should we be aligning by a role rather than figure out how to align by responsibility, or just we're trying to deploy secure software. So we have a role that you were saying of AppSec, who might be the gatekeepers, or saying, here's the checklist, and the developer is saying, wow, you just gave me not only a checklist, but a whole bunch of vulns that I'm supposed to fix, and do I need to fix all of them? So let's dive into a little bit what you were saying there about automation, and there's the common phrase now, especially this year, that I've seen quite a bit of, a developer first tool, or a tooling that appreciates the developer experience. So what does it mean or what does a tool look like that actually addresses what developers either need or could do better, or can help them with security?
Yeah, so most security feedback comes in the form of a PDF report. It's late, it's buried in a bunch of other findings. It's often very inaccurate, so it has lots of false positives and probably some false negatives in that report as well. And all of those things make it incompatible with the way people build software. We need to give development teams feedback on the code they're writing. It has to be basically instant. That's the most cost-effective way of doing application security. It has to be accurate, because false positives are a huge burden on development teams. If you've got a report that's, I'll be generous and say half false positives, if that's a massive amount of work for a team with no benefit. And if you're scanning, the faster you scan, the more often you have to do that work. It ends up being like mowing the grass. And so you have to be fast, you have to be accurate, and you have to be scalable. You can't be, a tool that you run every once in a while, or you scan as like all of your applications serially. You have to be running continuously in the background across a whole portfolio of applications. So those are just some of the ways that we're making it impossible for dev teams to succeed at AppSec with traditional tools.
Yeah, I want to pull on that thread a little bit when you're talking about false positives, or let's just call it the accuracy of the tool. Because on the one hand, it may be the case that the tool is potentially finding, especially in software composition analysis, that you're using this particular dependency, this particular library that has its own dependency that pulled in a jQuery, just as an example, that was used in the test branch for a test case, for a unit test, for this very long, deep path to it. But where I'm going with that is that just because that vulnerability is present and has a CVE associated with it, and maybe a CVSS number that's greater than 5, that doesn't necessarily mean it's exploitable. And I think that's a nuance too. And also talking about accuracy is, how can an AppSec team, or what's the better way for an AppSec team to have that conversation about priority? Meaning, rather than fix every single thing we're going to show you, fix these important things. And how do you both have that conversation to convince AppSec side that that's a good way to do things? And then how do you express that priority to the developers? Is it just do these top 10 things, or something else?
Well, I think many in the market are starting to realize that exact problem. And, it's relatively easy to just scan a repo for a list of the libraries that are used and the ones that are pulled in. by the dependency management tool. But really, that's like the easy part. The hard part is determining, and it's actually easy to determine whether they have vulnerabilities in those things because you can just look it up in a database. But the hard thing is figuring out if that library is really used and is it actually exploitable. And so, what we do for that is we watch the application run. We measure it in the background. So we can see every time a library is called, we can track it. And it turns out, we've done that across tens of thousands of applications and, real world business critical apps. And it turns out a very small percentage of open source code actually runs. If you look at the whole body of code that is actually the application, only about, if you think 20% of that is custom code and 80% is open source code. Problem with that, that's sort of the industry, mantra about the breakdown. It's not representative of the risk because only about 6% of that application is open source code that actually runs. All the open source, all the custom code runs. So it's the vast majority, 25% or so of the application is actually open source code that might be at risk. So you can eliminate a ton of those, known vulnerabilities that are in the libraries you're using by just measuring what actually runs. So that's one piece. The other piece you mentioned is interesting. You said a test library, and that's also really interesting. If you're only looking at the code repo, you can only see, kind of what's there in the code environment. You may not be able to tell that a library is a test library or a real library. We prefer to look at the application as it's assembled and running, because then you get that runtime reality. You can not only see what libraries are actually there, which ones are actually used, but you can actually see the context in which they're used. Are they related to a route that puts a credit card in a database, or are they an admin page or whatever? And you can also tell, so you don't see the test libraries there. And you also see libraries that aren't in the source code repo at all. Things that come from your app server. A lot of libraries come from your application server, and other ones come from your runtime platform. All those libraries get left out if you're only scanning a source code repo.
Now, a lot of this focus on third-party libraries that's big in the news, especially this year, with software composition analysis, dependencies, etc. I'm trying to avoid saying the phrase that rhymes with polar fins and how that re-put supply chain back on everybody's radar. But if we look at that and said, okay, here was a crisis, suddenly we need to care about security. What if instead we did something else that wasn't always crisis-driven? Is there a way to engage, security awareness, just security tooling within an organization that doesn't just have to wait for the next sky is falling event to convince everyone that, oh yeah, we probably should have paid attention to this?
Yeah, I feel like it's the fundamental failing of human nature here that we're not able to see very far ahead. There's a lot of people in the security community that have been talking about what do you call polar fin style breaches for a long time. I wrote about it in 2009 and said, hey, you got to make sure that your supply chain is protected against malicious intruders. But unfortunately, we don't seem to be able to actually do anything about that until it really happens. In some ways, it's like other crises that we're experiencing, like global warming. We've been saying it's coming for a long time, and now here we are, and there's massive hurricanes and stuff. So yeah, I'm not too sanguine about the future that way. I think unfortunately, it's going to take a catastrophe to really spark action.
So maybe then, I've read some science fiction from the 60s and the 70s talking about overpopulation, climate change. So not necessarily something new, but maybe what might be new, or maybe we're looking for a silver lining, something optimistic. You were talking about measuring and metrics before. So maybe what if we turned this around to say, just what are some good ways to measure your application security? And there's the common questions are one from the application security team. How many apps do I have, and who owns them, perhaps? But then the development side, or maybe like the CISO or the CEO is going to ask, how secure am I? How do we get towards better questions than that, or better ways to be able to say, quantitatively or a bit qualitatively maybe, here is what your posture looks like. We're doing well, we're doing worse, we're doing good in this area, we're doing bad in this area. That type of thing, to be more strategic thinking.
Yeah. So I'll talk about the big picture here first and then zoom in on a couple of specific metrics. But the big picture here is that I think the software market's broken. Like, we don't have a lot of visibility into what the security is of software that we're using. So for instance, many of you probably bank online. You probably don't really know anything about what your bank is doing to make sure that that online banking app is secure. And it's sort of, all the security details are shrouded, right? There's no way to get access to them as a consumer. And I think it's interesting that the new Biden cybersecurity executive order has put an emphasis on some of that disclosure. They're looking at things like SBOMs and software security labeling to try to expose some of those details so that the market failure around security can be fixed a little bit. And we'll see where that goes. I think it's really interesting. I think as a consumer, I feel like I have a right to know a little bit about the security of the software that you're using to do my financials and my healthcare and my military defense and all the other, my elections and my power grids and so on. Like, I think there's a public interest in making that information available. So I don't think it's an overreach. In fact, I think it's the sort of the least intrusive way that government could intervene in the software market to try to fix that market failure. So I think that's really important. In fact, that's why we made the mission of OWASP from the very early days. We said the mission of OWASP is to make application security visible so that people can make informed decisions about risks. And I still think that's the right thing to do. That's the way we change this market, because when things are visible, people can make better decisions. Now, your question about what metrics can folks use? You mentioned a really simple one like inventory. That's it's tough for a lot of strange reasons. Right. The simple idea of inventory is hard, but you should definitely measure what apps you're using, what software you're using. Automating is great if you can build a central repository of here's all the open source I'm using, here's all the custom apps I'm running. That's something that we've spent a lot of time on at Contrast, and that we think is really important. But I actually think if you're trying to measure, am I secure enough, you have to do it against a threat model. And one of the cool trends in the industry is that threat modeling is becoming really much more popular. It's now required by NIST in the new the minimum standard for software security testing that they put out. It's required in the PCI. It's required in the new OWASP Top 10 that's coming out in really short order. So all those are really good trends, but you have to have a threat models. And then against the threat model, you can say how well you're doing. Most organizations don't really do that. They just run a bunch of tools. And so they don't know what it means when they get the results of the tools and it says, hey, you've got no vulnerabilities or some vulnerabilities. It's hard to put that in context against, like, do we have the right defenses and did the tools test the things that were important for this app? So that's if you want to measure security directly. But if you're thinking about, how is your program doing around security? I think one of the best measures is the mean time to remediate. And if you measure, when I discover a vulnerability, how long does it take to actually fix that? Industry average is like 4.5 months. That's way too long. So if you're doing AppSec right, if you've empowered developers to do their own security, that number can come way down to like a week. And we have a number of customers who push that down even to just days or a day at large scale. So that's really exciting. The other metric I really like is a measure of, is the number of new vulnerabilities you're introducing going down? That would imply that you're learning and getting better at AppSec. Mm-hmm. We call that the vulnerability escape rate, just like a normal defect escape rate in software. And what you want to see is that number come down. We've seen across lots of customers, that number coming down to under 1 a month. With it's a little different for critical vulns and less serious vulns. Critical should go down to almost 0. So anyway, that's those two measures together. can be a really good proxy for whether you're doing AppSec well.
I love that, because one of the things you also avoided mentioning, which I think was quite intentional, is that you didn't really talk about the total number of vulns, just how many vulns are in an application. You were focusing on, I love the escape rate, the idea of how fast you're fixing, getting it down from months down to an order of days or even shorter than that. And that to me really speaks to things that the dev team can influence. So it sounds like you're actually showing behaviors that are desirable, the behaviors that the hopefully AppSec and DevOps are working together towards. So with that said, I kind of want to dig into this idea of vulnerabilities, that fixing those threat models a bit more. How have you seen conversations evolve with either who's adopting tools like Contrast has? Is it the AppSec team that's driving it? Is it the developer team? And when they're looking at, and I often like to ask multiple part questions, so hopefully take some notes. When they're looking at these tools too, they're not necessarily looking at every single vuln, but maybe they're looking at classes of vulns. And do you see threat modeling and like classes of vulns being able to lead discussions into better addressing root causes or adopting better frameworks to get rid of these classes?
Yeah. So, with regard to the first question, lots of big enterprises use Contrast because we do scale really differently than scanners. Contrast, does security from the inside. So, we're using instrumentation to measure security from inside running applications. And therefore, we can do it really fast, really accurately, and we can scale. Sort of the three criteria I started with. It's a very good process fit with the way people build software these days. Personally, I think the key to successful AppSec is to empower development teams to do most of the work themselves. If you have a process where the security work is going through a centralized AppSec team and they're a gateway to going into production, you'll always have backlogs and always have delays and frustration. I think that's an anti-pattern, is that the AppSec team needs to become more like coaches and toolsmiths and less a part of the critical path, like part of a pipeline. It's just too slow. And I'd say the same for sort of legacy AppSec tools, by the way. If your scan takes hours or days to run, it's not going to fit into a pipeline that has a 15-minute SLA. There's just no way. So that's kind of the big picture flow there. What was the second part of your question again?
Yeah, no, that's my fault. Well, because it's sort of that idea of looking at this from the perspective of we've got tools to help us find vulnerabilities and prioritize those vulns so we can be smarter about fixing them. I'm also curious the opposite side, sort of a proactive step to say, are there different frameworks? Are there different designs? And this, I think, leads to some of what you're describing with the threat modeling. Is there something that comes out of threat modeling or these discussions that say, you know what, we could even we could address this escape rate by making these kinds of choices? And I'm just kind of curious how you've seen those conversations go, or if there's good advice for listeners to how to seed those conversations.
So early on, I think it starts with that visibility. If you're discovering vulnerabilities kind of one at a time, it's often, the tendency is to just go make a point fix. But if you can see them at once together, you often have the opportunity to make a more strategic fix, right? So you can change out your architecture a little bit and maybe put a validation component in place so that everything gets validated, or stop using a library that's susceptible to expression language injection or things like that. You can eliminate a whole bunch of vulnerabilities at one time that way. The more strategic security architecture decisions, I think, are informed by threat modeling. And one of the things that we try to do, threat modeling is an expert-based activity. It requires some expertise. But what we try to do is create what we call security observability. We try to make the things in an application that are relevant to security architecture decisions visible. And it's different than just trying to find a vulnerability. That's like a very kind of narrow thing. But we try to expose the architecture. So for instance, like we might instrument access control and say, here's all the places where you're doing access control checks. Here's the roles that you check for by route across an entire application, and sort of show you where you have potential gaps. And that's a place where, some expert has to look at it. Maybe it could be an expert on a development team and say, hey, this doesn't look right. Like, why does the admin page not require a check for the admin role? It's only checking for, guest. That kind of thing is really difficult to test for with automated tools. But if you make it observable, then it's easy for almost any human to look at that and say, hey, that's a problem. That's something we need to jump on.
That's pretty neat, because to me that speaks to kind of a holy grail of all of these automated tools, whether they're SaaS, DAST, what have you, in the sense of what's the context of this application, or what's the business context of this workflow. And OWASP has that, or has sort of that business logic, vulns, which is again one of those easy things to say, but kind of difficult to pick apart and really difficult to test for. So what are some things there that you see, what kind of hope is there in the future of tools getting better automation around this, or enhancing the type of observability you're describing?
Yeah. Well, first of all, that term business logic vulnerabilities is abused a bit. It ends up being a catch-all category, meaning anything your tool can't scan for. Look, it's good marketing, but it doesn't really make a lot of sense to me. Like, I've worked, I've done lots and lots of manual pen test, manual code review work, sitting down with teams, doing threat modeling, doing security architecture. And the real business logic vulnerabilities are the ones where you actually have to understand the business. Like, if you're working for a mutual fund company, you have to know that a certain kind of funds can only be bought by people that are 65 and over, and that there's a mandatory minimum on the funding level for certain kinds of funds and things like that. Those are business logic, because you absolutely can't know them at all without understanding the business. But most of this stuff that people are calling business logic really are just their security controls, right? There are things like authorization and access control and certain authentication things that they just can't scan for. And that's unfortunate, because a security person could look at that and say, oh, well, that access should never be allowed. So it's not really, to me, it's not really business logic. But putting that aside, I think the key to those things is making them visible, making them observable. That's when you can break through and get the people that understand how they're supposed to work to look at it. One of the things we do is we generate an architecture diagram of sorts. We call it a flow map for every application. And we break it down. We show you what routes come in. We show you the components that are involved with each route. We show you the back-end connections. We even show you the other systems that are using back-end databases. So, if the app you're looking at accesses database A, we can show you, and these other 3 applications, B, C, and D, also access that database. So you can try to start putting these risks in context of, what is this function trying to do, and what data does it have access to on the back end, and how sensitive is that? That'll allow you to get a much more accurate risk rating than just someone saying like, well, all cross-site scripting is high or something like that.
No, and I think that kind of points to, too, you haven't mentioned this aspect of it, but I'm going to kind of guess that if you can see these flows and you can understand just what the code is executing, that might also give some credence or some benefit to the developer side of the house to say, maybe we should just delete a whole bunch of code because it's legacy, it's not being exercised, it's cruft, it's increased attack surface that we don't need. So I'm kind of curious, have you seen those types of conversations developing?
Yeah, absolutely. I mean, the key to getting developers to understand security and do the things that you want them to do is to really show them why it's a problem. And you look at something like a DAST tool and it just says, hey, there's some SQL injection on this URL. And that's it. You got to go find it, right? It's a lot of work. SaaS has the other problem, like it says, hey, there's a security problem in this code, but it doesn't say anything about how that code gets invoked, what HTTP request is invoked, what drives it. It's just kind of a line of code with a problem. And so you don't have the context to actually understand it or test it. Our approach IAST shows you much more. It shows you the HTTP, it shows you all the lines of code involved, and it shows you things that other tools don't provide, like the actual data flow, resulting in the entire SQL query that's about to go to the database. All that context makes it really easy for a developer to say, oh, I see, that data came from that parameter in the HTTP request, went through these lines of code, and ended up in this query where I can see it right there without being properly escaped or parameterized. That context makes all the difference in getting them to do what you want. And so then they can make those decisions about how to fix it. And I think you're right. If you show them vulnerabilities in a part of the code they're not really using, or they could do another way, then they can just delete it. It's an easy way of fixing problems.
Easy way indeed.
Question around exercising the code. One of the common things in this space, one of the common issues which a lot of startups have in this space is how do you actually exercise that code?
Yeah.
So maybe if you want to talk a little about that. I know the phrase unit testing is going to be involved. I'm just very curious, how do you guys get really thorough coverage, right? Because it's if someone has a bit of code which only gets called once a year, how does the IAST get to it?
Yeah, it's a great question, and it comes up an awful lot. So every application security tool has a coverage challenge, right? DAST tools don't cover very much of your app. You can measure it with a code coverage tool, right? You can see it. It's very difficult to crawl an application and exercise all those forms. Static tools also have a coverage problem. It seems like they should be hitting every line of code, but that's really not how they work. Static tools build a model of your application from the code, and then they work from the entry points. They follow the code paths through the application, and they try to calculate things like data flow vulnerabilities and injection flaws and access control issues and so on. And they make a lot of mistakes because it's really hard to do that statically. I heard an expert in SAST once say that their tool only followed 15% of the code paths, which is not surprising because it's really difficult. We think the right way to get code coverage is to use the existing QA process that folks use, whether it's automated testing or manual testing. Folks are exercising their applications. You don't put code into production without having run it somewhere in the development process, either in dev or automated QA or in manual QA. Somewhere somebody's running code. And by aligning security with that manual testing, we're creating a lot of momentum towards getting to really good coverage. So what Contrast does is we measure all the routes that have been exercised by the application. So your application might have 50 routes, it might have 1,000 routes. And we calculate that. We interrogate the framework. So we know exactly what all the routes are, all the exposed attack surface, essentially. And then that's the denominator, if you will, right? And then as you use the application, we track, here's all the ones that you've hit. And so as you use the application more and more, your coverage goes up and up. And most of our customers, after a few months of using the product, get up into the 80s in terms of route coverage. That's pretty good. Certainly better than what I think SAST and DAST are capable of doing. But because we're aligned with testing, we've had security teams going to their testing groups and saying, hey, we've noticed that there's these 50 routes that aren't getting hit during testing. Are you guys testing those? And they may say, well, wow, we didn't realize those routes were exposed. Maybe we'll turn them off, or maybe we'll test them. But we're increasing that route coverage, and it's been really awesome to see development teams and security teams working together that way to drive forward both quality and security at the same time by doing the same thing. That to me is really an amazing way for security and development to work together. And I think it's working really, really well.
I think maybe one final question for me, just to piggyback off what you just said there too, is we've been talking this whole time about an AppSec team and a DevOps team, and then at the end there you're talking about the app and dev working together. Do you see, or does it make sense to have just a natural collapse of those two groups, just saying we're the same team, we just maybe have slightly different responsibilities, but the tooling is here and et cetera, and sort of, or is that sort of an approach and a maturity model for a particular org? Just how would you like to see that evolve?
Yeah, I think I think ultimately those two functions need to merge together. The same way that performance engineering and quality engineering and so on have merged into development. Is the whole point of DevSecOps is to break down a lot of those silos. I don't think many in the security community have really given up on the traditional way of doing security. They still want to have their lists and their compliance and their checks and so on, and they haven't really committed to doing security a different way. I wrote an article recently called "Building Security in a Software Factory," and the point of that paper was to try to show people how to package the work so that the development teams could execute on that. And then security becomes more like a product team. It becomes really part of product. Like, let's define the things that we want the development team to work on. And then the development team executes them and delivers into production, not only running code, but assurance that the right security has been done along the way, so that you can have confidence that the software that got created is trustworthy. And to me, that's the whole point of security engineering, is to produce that assurance so that it's not only that your software is secure, but you can actually show somebody else and give them an argument that says, hey, we identified the right threats, we built the right defenses for those threats, we tested those defenses, and here's a pile of evidence that shows that these defenses are both accurate and effective in terms of defending the application. That to me is the whole point of what we're doing. And unfortunately, it's not something that most AppSec practices are generating. I don't know if you look at what an AppSec team is generally producing and say, explain to me how we defend against clickjacking and how I know that defense is in place. They probably have a pretty disjointed answer, like, oh, well, we did some training and we ran a tool and we think the tool finds clickjacking in this application, but we're not sure because we're using CSP and not X-frame options header. Like, it just the argument is not very well formed. And so that ultimately, I think that's the change that we need is to get teams to produce that argument more effectively.
Yeah, well, I think you've brought us a quite excellent argument and background on better tooling, what developer-first tooling should really be, and I think what a good roadmap for AppSec and Dev to work together, to be honest. So I want to say thank you very much, Jeff, for joining us.
Thanks, it was my pleasure. Really great interview.
This is a wonderful time. We'll have to have you back because I think, speaking of piles of evidence, there's a pile of evidence that you've got a lot more to share with us, so you'll have to come back. Also
Thanks,
want to say... Wonderful. Also want to thank everybody who's been listening so far, as well as John for joining us. We're going to take a quick break. But before we do, I have to sneak in. If you want to learn more about contrast security, visit securityweekly.com/contrast. And now, in fact, we will officially take a quick break and return with news of the week.